Today, we're going to talk about a beloved 90s video game and connect it to something that, well, it makes a lot of people nervous: algorithms. And we're going to do it by chasing the world's most famous thief in a red trench coat. So, when you hear the word algorithm, what pops into your head? Probably a bunch of complicated code, right? Abstract math, something that only computer scientists deal with. But what if I told you that you actually mastered one of the most important algorithms by playing a video game as a kid? You know, at the heart of all this is a really powerful idea. Being right isn't about some flash of genius. Nope, it's about having a disciplined process. It's about following the rules and just systematically shrinking the world of what's possible until only the truth is left standing. And the classroom where you learned this amazing skill? It was the classic game Where in the World is Carmen Sandiego? That's right. Every single time you fired up your computer to play, you were secretly getting a masterclass in computational thinking. Okay, let's dive into this. The key thing to get here is that we have to totally reframe what the game is about. You thought it was a geography quiz, didn't you? We all did. But it wasn't. It was actually your first lesson in how to build a logical proof. So here's how the game works its magic. On the surface, you've got this fun story, the narrative layer. Carmen stole something, you're a detective, you're globetrotting. But underneath all that, you're actually dealing with the problem space. And what's that? It's a fixed set of suspects, a map with limited routes, and a clock that's ticking down. That is the real game. That's where the algorithm lives. And here is the crucial pivot. The game secretly teaches you to stop looking at clues as just random facts to memorize. Instead, you learn to see them for what they really are: powerful rules that tell you what can't be true. They tell you what's now off limits. And this idea, it has a name. It's called a constraint. See, a constraint isn't just a piece of info. It's a rule that eliminates possibilities. A clue about the suspect's hair color is just useless trivia until you turn it into a rule to start crossing names off your list. Just think about that mental shift for a second. A clue like the suspect speaks French stops being this passive little fact. It becomes an active command. Eliminate every suspect who does not speak French. All of a sudden, you're not hunting for the right answer anymore. You're systematically proving which answers are impossible. All right, so let's see how this actually works in practice, because this is the fun part. With every single new constraint you get, your world of possibilities gets smaller and smaller. And as that world shrinks, your certainty just grows and grows. So at the start of any case, the world is just full of possibilities. You've got this lineup of 8 suspects. Right now, it could be any of them. The thief is out there, hiding in this crowd. But then you get your first clue. Now, this isn't just a piece of trivia. Oh no, this is a weapon. This is the first constraint you can use to start making the world a little smaller. And boom, just like that, the world shrinks. A lot. By applying that one simple rule, we've lawfully eliminated 5 of our suspects. Our list of 8 is now down to a much more manageable 3. The chase is on. A second clue arrives. And this gives us another constraint that we can just layer right on top of the first one, shrinking our world even more. And you see how the proof just starts to build on itself? We apply this new stamp collecting constraint only to the suspects we have left. Sorry, Dazzle Annie, you're out. Now only 2 possibilities remain. We are getting so close to being certain. And after one final clue, let's say the suspect drives a motorcycle, we are left with just one person. Now, this isn't a lucky guess. It is a logical proof. You've reached certainty, using nothing more than lawful elimination. You know, this calm, methodical process of getting to the right answer, it actually has a name in computer science. It's called the detective engine. You weren't just playing a game. You were running a real proven algorithm for finding the truth. Now, this whole process is protected by a concept called an invariant. Just think of it like the one golden rule you can never, ever break. In this game, the invariant is simple. The real thief must always be on your list. The second you eliminate a suspect by mistake, you've broken the rule, and your whole proof just falls apart. So, that intuitive process you were following as a kid can actually be formalized into these 4 steps. First, you define your space, all the suspects, all the places. Then you extract the constraints from the clues. Third, you eliminate everything that's now illegal. And finally, when only one option is left, you finalize your proof. You issue the warrant. That is the Carmen Sandiego algorithm. And this
This is where it all comes together. This detective engine, this whole method of defining a space and shrinking it with rules, it's not just for some old video game. It's honestly one of the most fundamental concepts in all of computer science. I mean, you are looking at the exact same logic that powers algorithms we use every single day. When a program does a binary search, what's it doing? It's just eliminating half the data with each guess. When your map app finds the best route, it's eliminating all the longer, impossible paths. You already have the core mental model for how these super complex systems actually think.
So the big takeaway here is that you've had this incredibly powerful problem-solving tool this whole time. And you didn't learn it from some dry, boring textbook. You learned it by chasing a thief around the world. And because you learned the feeling of it first, you can now recognize that logic and use it absolutely anywhere.
And that kind of leaves us with a final thought, right? In your work, in your life, how many problems are you trying to solve by desperately hunting for the single right answer? What could you accomplish, probably more calmly, more elegantly, if you just stopped searching and simply started eliminating what's impossible?